All right, let's get it started. Thanks for joining this session. Today we're going to talk about the identity observability with the knowledge graph. So there's a small title there, beyond monitoring and the enforcement, because we're not just talking about monitoring, but also enforcement. Further slides talk about myself. My name is Chen Xi, security engineer at Boston for just a month. And I'm also an author for a Kubernetes secrets book. As you can see, my specific domain lies on the secrets management, key management, workload identity, and infra security. Yes, 1 month ago, I still working at Uber when I tried to send the proposal. At Uber, I built the identity observability system and zero trust architectures. So before we get started, there's one disclaimer I gotta mention here. All the numbers and metrics and data point here just for education. Don't treat it very seriously because these are fake number. I have to do that because I already leave Uber. I'm a former employee of Uber, and don't use the data point here to judge like how Uber system looks like. I don't admit to that. And also all the opinions are my own. Here's today's agenda. We're gonna quickly go through the problems and talk about the system we're building. And then most importantly, we'll talk about the enforcement. The last part is talk about the new challenges we're having. Oh, wait. So the problem we have is the IAM challenge at scales. So it's nothing about AI, nothing about the threat. It's just like an IAM system. The first question is, the modernized the IAM system always grows from the beginning. If you look at the companies, when the company grows, the IAM system grows. So take Uber as a quick example. So it has some very quick like a growth speed stage where we have a lot of new employees come and join the companies. Everybody coming into the company and they get an assigned task to say, hey, you need to fix this tomorrow. So they check the code repo, look at the different database and internal tools. What is the quick and easiest way to grant them permission? Group, yeah. We're building the internal group systems. And when the first day they join, we just assign them into the group and they automatically get the permission. All their systems across different like whole ecosystem, just check, hey, is this person belong to this group? Great, now let's just let him to access the resource. We're just growing so fast. Everybody needs to do their job. Let's do it quick and dirty. Second stage, there are frequent reorg. We have managers, we have like new people join the team. The manager feels like, I don't want to manually add the people to the groups one by one. Why not just, you need to give me a new feature. I want to put the whole groups on the other groups. And I automatically grant my whole team the permissions to unblock them as quickly as they can, which we define the birthright access. But there are other like necessary groups to expand the birthright to be more big and big. Now the situation becomes like a few years later. We're gonna ask a question. Hey, who can access to what right now? Regarding that assets, who can access these assets? So every time when we're asking the questions, it takes a bunch of hops, go to different systems, ask them to aggregate the data and come back to us. So it's literally a few years later, the IAM system became deeply nested, and it's very, very hard to answer some very basic questions because the whole ecosystem grows so big. Again, this is our fake number, but simulated number. At Uber, we have more than like 80K users. These users are pretty much not driver, nothing related to driver. It's just like internal user, employees, and people need to go to the hub, pick up the phone, answer the questions to the driver. These are Uber employees too. We have more than 1,000 SaaS applications. And most importantly, we have more than 100K groups. And like the assets number is a fake one, but we have more than 1 million, okay? And also we have to define the assets here. The asset here includes, some technical issue. Is it back? I think there's some connection issues. Okay, we're back. So continue the assets. So it's abstraction concept. The assets may include hype tables, secrets, all the internal microservices and data assets and all of them. So definitely more than 1 million. But if you look at these scales, the IAM system we initially built really falls short. It's the first one is like the hit and blast radius, because we cannot answer, like it's not easy job to answer the basic questions like who can access what. And also it's like every time when we change this, when we do some small change of minimum group change, the impact cascaded into like thousands of assets. Like every time you touch a small change with a group, automatically they get like granted permissions to thousands of assets. The second part is like there's no access visibility. We literally don't know who can access what. The last one is we have a large security organization. Everybody wants to do some project, make impact. But what exactly the impact looks like we have to some way to measure what is the top priority for us. What is the data? What is the number you can solve? So this comes into the second part. We are trying to build a system with data and a platform to answer all the all the narratives of the IAM system we are building. But before that, we need to answer the first layer questions. What kind of data we have today? If you look at the internal system, for user, we have HR systems, we have employment types. When they join the new companies, we have the org, we have the management chain. It's actually pretty, like as an engineer, when I first time entered into the HR system, I was super impressed that it's so complex. And we also have the IDP system. Yes, we do have a centralized IDP system, but integrate with different systems. We also have an internal cloud resource, and also internal SSO system generated the service account, created a service account user and inherited the group rules. Lastly, some smart people, they try to invent a system named the owning system. We want to make system like more generic, abstracted, so they try to mapping the groups to the internal assets. We have that data. We have the data. We also have the pipeline where bunch of teams try to clarify the user based on their employee types and define the risk scores. And then for all the assets, we try to do a lot of work to clarify the sensitivity of the data because it's a compliance requirement. It's a separate effort, but some team is driving, it is there. All the data we have, yes. But we never get a chance to have a system to connect them together. That's the major topic for today. Based on the data, we put a bunch of efforts to leverage the GraphDB to building a security knowledge graph. So this is pretty much an oversimplified GraphDB model. So the core part are 3 nodes. We have user, groups, and assets. Between these nodes, we build the edges. There's a sample edge here, like a user is a member of a group, but also an indirect member of a group because the group potentially can be deeply nested and even cycling. From the group to the assets, we're checking a bunch of systems. We're building the edge like a has assessed based on the auditing log. And also we're building the edge like can assess, like which parts grant them the permission. Again, this is oversimplified. Internally, we have more than 50 edges between the 3 nodes. There includes permissions, policies, and everything. After we're building the system with the data and GraphDB, now finally, we can answer the very basic questions regarding the query. Hey, how many users can reach to the assets now? 1 query, you get it. What is the blast radius if I change some group? What is exactly the impact? And also, most important part, a lot of cases we have to do reverse lookup. Beyond like who has assessed a specific system, we reverse look at that. What else he had assessed? Has he accessed to the data system or just like internal database or other microservices? So I probably won't go through the details of these slides, but like this is a like high level compare between the relation DB and the GraphDB. So in the IAM world, so if you try to answer the questions in the like left side, so for relation DB, every time we need to ping the team and talk with them, and so after the complexity join, ask them, hey, can you run the query, get back the result to me, or expose the result into a Excel spreadsheet or something, share with us. But now with GraphDB, we link all the data together. It's much, much easier. And most importantly, I want to emphasize that it's you can do the subgraph query, and also you can do the bidirection by default. And the cascade analysis is not a big issue now. Oh, more importantly, for RelationDB, join is not fun. Cross multiple table join is not, it's always not fun. You have to trust the data engineers always give you the correct answer. But reality is, well, not good. All right, so we won't pause the story there. Yes, we have the observe. We can answer the question. Is that enough? No. So we have if you look at the IAM system, it's a house. It's a beautiful house, but it's a broken house. Because the company grew so fast, we have so many security efforts, but we also need to admit that the existing IAM system is a broken house. So the permission accumulated over years, nobody knows the full access picture, changes happens. It works, yeah, it works, but not great. Now with observability, so let's just take a step back. If you have a broken house, what are you gonna do? The first thought you are thinking about is, hey, let's try our best to fix this house, broken house. Which part is broken? Let's fix it. But more importantly, how about we build a new house? It's a running system. It's easy to say, let's build a new house. But it's not easy to do that. What are you going to build? What does a new system looks like? So identity observability fit into the gap on two parts. The first part, help you understand the structured issues. Take a nested group as a quick example. The deeply nested group causes a lot of structured issues. And most importantly, the identity observability system helps you to understand what is the initial user intent. If you look at the original question, a user jump into the company, hey, I need the permission to do X, Y, Z. That is the user intent. If you look at the user intent, there's nothing related with the group, nothing at all. But why that happens? Because you want a quick, dirty way. So our identity observability system can help you to print out the blueprint based on the user intent to tell you, hey, for the new architectures, how it looks like, what is the existing data looks like. Oh, it's broken again. I don't know what's happening. They're back? Oh. Yeah, it's back. Okay. So with that said, let's jump into the next slides. Beyond observability. To me, I think this is a core part if you try to build a new house. So we link the data, we put it into the GraphDB, we can do the continuous query. Now we can finally answer a bunch of questions. If you look at the life cycle of the auth end to end, there are a few stages. The first stage is pre-auth stage. Pre-auth stage is like, hey, a user wants to do something. That is a pre-auth stage. And with the existing data, it can validate and say, hey, there's other ways you can do. If we building a relationship between a user to assets directly in the pre-auth stage, you don't have to go through a group directly. Or if you have a JIT or PAM solution, you can, hey, we have the JIT PAM solution for the target assets. Now you don't have to go through the jungles of group. The second part is during auth. Step back to the previous problem I mentioned. All the systems try to make it very simple. A simple question is like whether this user belongs to this group or not. If yes, check, just let it go. With all the existing data we have, we can do the real-time blocking at the choke point. Now, it's not just identity observability can support the during auth stage that not just you have to belong into a group, but also who you are, what kind of specific user attribute you must have to access the target assets. It's a runtime guardrail system you can build for during auth stage. After the first two stages, there are after auth stage. The auth is already happened. The IAM auth is already happened. Now you get the auditing data. You can do the detection. But if you look at the detection, there's another problem, the ID aggregation. I didn't specifically mark the data here, but imagine that for a user, if you look at a user, if you look at the internal system, how many IDs can map into one guy named Chen Xi? It's very easy to say there are more than 8 or 10. I have my username, I have my employee ID, I have my email, I have my SPIFFE ID, UID, UUID, plus did I mention SPIFFE ID? Yes, we have like service accounts, all the things, all the IDs actually mapping into one person. In detection stage, one of the challenges they have is, hey, I look at some logs. These logs like show me some ID. I don't know exactly who they are. So one cool thing we did with like the knowledge graph is we actually export the ID into a separate table and ask the detection team, hey, just query and enrich all the data into like one format. And it's very easy to query for them and define a ruler from them. And there's one part I intentionally skip is the automatic remediation. So there are 2 data I mentioned before, can access and has access. So the percentage number is around like 1%. What does that mean? If you look at the group users within the group, the user really targeted into the system is only 1% of the permissions they have. So that means more than 90% of users can be removed from the group, even the group granted them the permission. So we actually built a automatic like remediation engine periodically to check the data to say, hey, these people need to remove from this group. So this is a very quick study how we use a graph-driven access reduction. As I mentioned, we periodically check the access log, find the people who haven't accessed the system or his peers. Because we have all the data now, we know who their peers in the same team, and we also look at the auditing log from their peers and determine, say, hey, you had never accessed the target assets within last 19 days. So we think that you don't need that permission anymore. So we try to run the engine, remove the people from the group. How many time? Okay, 3 minutes. Well, we can talk about a little bit more. So another thing is the risk score. Oh my God, I don't know. Give me 1 second. Let me see if I can fix them. Oh. Hey, please come back. Okay, it's come back. So I mentioned the unused permission. It's very, very useful because we have a broken house, but we have to keep it running. So we continue to do the remediation. But also we have the risk scores mapping into mapping to the user. If you find a user frequently leverages the system, talking to some assets his peer never accessed, or this user has some specific attribute, and we try to adjust the risk score a little bit. Then, as a loop coming back, and during the runtime, we try to challenge them with JIT and PAM system, ask them, hey, can you ask your manager to quickly approve, or can you quickly just give a Jira ticket? Then we just allow you into the system. Yeah, it's a lot of fun to using the data to power the different cases. The last slides, I'm going to quickly talk about because if you look at the system we're building, we're pretty much focused on the user and a group. But there's new challenges with the AI. So there's a typical question, the shadow AI. There are a bunch of AI, they try to get the permissions and granted by employee. They just get the OAuth granted permissions beyond the security review. If you look at the data, they're just like, hey, the user frequently talking to the target system. We don't know whether it's an AI agent or not. So there's a bunch of efforts to try to expand the graph to cover more cases. We try to collect the data, set the boundary to say, hey, these are pretty much sensitive data. We don't want these people to access this data. Also, we try to loop back and mapping the data flow paths and try to, from the vendor log, to check that, hey, why you're frequently talking to this system? Oh, you're an AI. Then we circle back, automatically tag and say, this identity is granted into AI. So long story short, if you think about the graph nodes, we're actively expanding the user node to the AI agent node. Yeah. And again, the last part, all the efforts is not for observe or observability. We shouldn't pause there. We're invented a system named context-aware enforcement, where during the runtime, we aggregate the risk scores, all the behaviors, attributes, and try to give a little bit hard time, even if it's AI. All right, so I'm about the time, and I'll try to summarize all the key takeaways. So as you can see, it's a lot of fun to build a GraphDB for modern IAM system. Simply 3 nodes and more than 80 edges can answer a lot of questions traditional relation DB cannot answer, especially if you have a larger scale systems across different departments, orgs. Every time you need to ask people to run the query, get the data back to you. Second part is the system should not pause there for observe only. The enforcement is a key. You have to leverage data during the access pass, give either people or the AI agents a little bit hard time. And the third part is there are a lot of business decisions you can leverage data to answer. Which one is important? Which one has the high risk? Which one we should address? So last part is, if you look at all the IAM system, you feel like it's not good, but it's a running system. What should we do? Build a new house? But how? You need the data to answer the questions like what is the initial user intent looks like and be the blueprint for the new house. Last part, very quick comments. It's not an easy job. AI agents introduce new challenges, but we're exploring the usage of GraphDB. All right, that's all for today. Again, thank you for joining this session. Feel free to leave questions and comments there. Oh, I saw one question.
Yeah. A little bit of an implementation question for your runtime blocking enforcement or your continuous monitoring.
Yeah.
Are you going back all the time to run a slower multi-hop graph query, or are you normalizing to a relational scheme or something else like that?
Excellent question. We actually tried both. Depend on the usage. Say if your runtime, there are different runtime and different latency requirements. So let's take a quick example. If you're people, if I can get a response less than 500 milliseconds, you're still happy. So in GraphDB layer, we have the cache. We verify that most of the queries can hit the cache, give you a response back around 100 milliseconds. You're happy. But there's still cases that you're not happy. You want to run it as fast as you can. Yes, you're right. We actually normalize the queries and export the data into a relation DB. And then for you to, this kind of data is pretty much like a static data. For example, the user ID and user attribute, you're not frequently change it because your upstream IDP system is changing that every 24 hours, right? So we can just every 2 hours, we refresh data, run the query again, export it into a place.
Okay.
Yeah.
Thank you.
Yep. A new question.
So first off, I was kind of disappointed with the talk because you saved it at the end because you magically sprinkled some of that magic AI pixie dust at the end. So thank you for recovering a little bit of that.
Yeah.
But the question is when you're making the changes, when you're recommending changes, either automated or looking at reviewing parts of the house, are you looking at the edges of the graph and saying, here we can do things which have less impact, right, and not as many of the dependencies, right, and then building that up over time, or are you trying to change things at the center of the graph, which have a lot more dependencies and things, but that's probably the biggest bang for the buck you can get? How do you determine when to start making changes, edge or center of the graph?
Yeah. Excellent question. I hope I can answer this with all the details. But the short answer is we're pretty much focused on the edge. We're pretty much focused on the edge, but not the node. Okay, so let me think about how to answer more. Because there are a lot of user scenarios we have to simulate and try to build a relationship. So we're not we don't want to touch the node too much. In fact, we want to build a system, as I mentioned, we need to expand the node in very limited cases. But for most cases, we still want to focus, to build a relationship with the edge. Yeah. Because they're also related with query. You don't want to jump to multiple hops to get results. Yeah. Go ahead.
Hi, first off, I like the amount of AI in your talk. I think that was nice. I just a little bit at the end, so keep it there. But my real question is, I'm wondering, as you were working on this graph, did you start to have interactions with other teams? For example, I don't know if there's a red team that's dedicated to split who wanted to do things look at it and say oh, this user was compromised, or this database was compromised. We want to understand the impact of this database being compromised, but then also then you need to know something about what is in the database, deal with that kind of data tagging, and then how did that go?
Yeah, this is an excellent question. So actually, this is a small story. Before we launched the project, we already have an effort from the internal SRE team, because this is exactly the questions they care about. Every time they're suffering because they need to talk with for example, the database, they need to talk with database team. And all the microservices, they need to talk with compute team. And they need to understand the whole architectures. It's very much painful for, I would say, most of red teams, they are security folks. They're security folks. They're not infra folks. They're a software engineer part. They knows the enforcement part, the existing, how the IAM system works. But every time they have to bridge to the software engineers working on the security space and talking with the different teams. So first, yes, you're right. This project initially was driven by the red team, because we want to draw the attack graph. But after that, after we build the system, we go beyond that because we want to use the data to power the runtime guardrail. So I hope I answered your question. Yeah. Yeah.
So the question is, ultimately, the end goal is to have that graph DB as the policy decision point, while you have as many policy enforcement points across your infrastructure as possible, so that graph eventually becomes your source of truth for policy decisions, while every critical asset is protected by a policy enforcement point that would query or question that policy decision point for up-to-date data. Is that?
Yeah. So very good question. Be honest with you, my personal opinion is the GraphDB today cannot be the only source of truth. The reason is it's the bottom pipe. It gets the data from the upstream IAM data. It's not real-time data from the data source part. It helps a lot in the risk analysis. But if you think about that one, there's a small circle to set the boundaries for a lot of assets to say, hey, you cannot touch this space. For this part, I would say we still stick into the static policy. Yeah, but beyond that, there's a larger circle to say, hey, I think I need to grant you permission quick and easy, and also sometimes challenge you with risk. Then choose Graph. Yeah. Thank you.